DraftScience video response to Daftloday, and another arrogant and bold video by him. He's making for dummies video. You could sort of argue that when people do the for dummies videos, they actually have to be more expert than people not making a for dummies video. Because it's really dumb when the people calling other people dumb are making dumb mistakes and being really arrogant and obnoxious while doing so. So anyway, glaring mistake in this video. I guess I'll play the video just to be fair to it, but I should just get to the middle where he makes the glaring error in his assumptions regarding how the experiment functions.
Forgot to take account of DraftScience's sensibilities. Let's spell it out for the cheap seats, for the dummies out there.
Right, for the dummies out there, let's spell it out and spell it out incorrectly. And you know, this is just the arrogance. There's no other word. I mean, whatever. You know, it's this confidence in a subject that's always much more. You know, there's many more moving parts than these simple descriptions. It just goes back to the two-slit example where every single description of the experiment, they will frame it in such a way of displaying the single slit and the double slit to imply the single slit is uninteresting and that it's the double slit that has the interesting pattern. And it's just not accurate or fair or correct. It's fucking wrong.
Right. This is what Emendum surely will not deny.
Oh yeah, so again, this arrogance in the face of just a gross error in understanding.
We can have a source of light. Okay? We can have a beam splitter. We can shine a source of laser light at the beam splitter and note that on a screen we get two images, okay, two spots, and we can say to ourselves, hey, we got a beam splitter here. Now, this is a stream of light. The experiment deals with a stream of light. We never consider individual particles, although we might in an explanation, and we might try and draw that. But the experiment is about.
So let's understand that the whole theory of quantum mechanics, Heisenberg, Huygens, well, not so much Huygens, but the whole theory behind quantum mechanics, the reveal wasn't the Young experiment. It was the later French experiment of doing the single photons and realizing the exact same pattern is revealed. So there's no issue anymore with any discussion of, oh, it was the photons interacting with each other, that, you know, many photons go into the two-slit experiment and the many photons interact with each other and create the pattern. So that was the whole point of the quantum mystery, is the fact that no, just every single photon somehow knows this probability equation, and that it has nothing to do with a photon A and photon B interacting. There's no evidence in any physics I know of, any experiment I know of, where individual photons interact and create interference. There's only evidence that single photons have some sort of wave feature, some sort of wave function, some mechanism that stimulates the electric and the magnetic fields and somehow makes the single photon create a mechanism, a radiation, something that makes them bigger than they are, however you want to look at it, and it interacts with itself. It interacts with a copy of itself, we could say, if we're just going to use loose jargon. The photon creates two images of itself, and the two images of itself, the two holograms, interact with each other, and then the end conclusion is that the real photon goes where the image went, where the two images mix. That's the probability decision. So there is no scientific evidence of two photons destructively interfering or constructively interfering. I can't take two beams of light and make them interfere. Individual photons interfere with themselves. So he doesn't even get that part of the quantum mystery.
Absurd quantities streaming from the source, and approximately half going either way. We could put a meter here, and measure the intensity and say, hey, we got ourselves a pretty good 50-50 beam splitter here. And then, what we could do, we could say, hey, what if, through a beam splitter, instead of a screen, we place a mirror? Wow. The mirror will send the prior image and light back on itself. Boom. So we have the source. We have a split. We have...
I'll just say again, yellow isn't a great color, so but selecting colors, yellow isn't a very good one. So again, this for dummy part was just superfluous and useless. There's no point being made here. We know that what a beam splitter is. That's not the issue. There's lots of issues about what happens in a beam splitter, and I guess I'll have to get to those.
Split. We have the returning light from the mirrors and the images. But whoa, it's going to meet a beam splitter again, and it's going to...
So he's got all this animation to this ridicule just laced in this video, when it's just so poorly founded. His foundational knowledge of the experiment is weak. And he's going to make an incredibly weak argument in this arrogant, buffooning, ridiculing manner. And it's, the irony of it.
Do something similar to what it did in the first place. What's it going to do? It's going to return half the light back on itself. Now, by and large, for the purposes of this experiment, we don't think much about that half a light, because what these returning images are also going to propagate this way, half. Because we confirmed this, because we could have set up this experiment and placed the source on the other side and confirm.
Alright, so I might as well at this point point out what is fundamentally wrong in what he's saying in terms of his understanding of the light returning and in what form it returns and what is measured exactly. So I will go to the drawing table, I believe. So I did a little better drawing of it, but it's, I don't know why the focus and resolution just isn't as good as it should be. But anyway, so the solid blue lines just go through, and then the red lines come back, just indicating two solid red lines coming back, and then there's two dotted lines of red that go in both directions, indicating the splitting of the beam. Now, the catch to this experiment is what is seen at both locations isn't just a dot of light. It's a pattern of light. And so neither path can ever produce on or off. It produces a different pattern. I should have put these two obviously much further apart, so I'll draw another one down here. And so the idea is going to be that these lines will alternate exactly opposite in these two patterns. So if this one's dark, then this will be dark, and the outside will be dark. And if this is light, then this will be dark, and this will be dark. I mean, oops. This will be dark. And then this will be dark. So this is one. So his first fundamental misunderstanding is that when he says streams of photons are going through, he's assuming that two photons come back and they somehow interact with each other to create an interference waves that interfere with each other, and somehow two photons go to the location of the interference pattern, the probability equation. Obviously, that doesn't work with any interference knowledge we have. We can't take two actual photons, make them interfere with each other, and then both the photons end up at the location dictated by the probability. So nothing about this whole quantum mechanic theory is consistent with what he's attempting to argue in terms of this is some sort of massive photon argument. The reason why you can't do for this interferometer experiment single photons is merely because it's a motion experiment. It's an experiment done over time, and obviously single photons won't give you an image reveal in time with the experiment, so you won't be able to see the changes that the experiment is producing at single photon at a time rates. You'll only see that you might get only photons in this ring, or you might only get photons in this ring, but you won't get a complete enough picture of these patterns. Should make this a little darker just to be clear. So both beams are creating those patterns on both of these legs. These patterns show up. So if this pattern is at this leg, this pattern will be at this leg. But there's no all on or all off when the experiment has both legs open. That doesn't happen. So I guess we can continue. So he has two misunderstandings. First, he thinks there's some evidence that photons interact with photons when they don't. And second, he thinks this little center that is often shown. So you can focus the projected image here, just showing the center, or you can show the whole thing. And as I've tried to point out, I've stated and proved in many ways. I showed the thin film that projects the let's see, there's probably room over here. When you shine a light on a diffraction gradient, it creates a huge deflection in the pattern, and you get this, these separated dots, the brightest dot in the center, and they spread out. But this spread happens over just a foot or two, a tiny amount of distance, and gives you a huge divergence. So that's what a diffraction gradient does. That's what a half silvered mirror does, is create a huge amount of diffraction of the light. And so it's spreading, and so you can sort of think that if you're viewing it, you could just view what's happening to this center and not view what's happening to the whole, what happened to the rest of the light. So typically in this experiment, there's a laser beam going in, and these images that are resolved, that can be resolved on both legs, they're usually just resolved on this one leg. The image is, a tiny percentage, 1/10 as bright as the laser that went into the experiment. So not only are you losing half the light this direction, but you're also losing a substantial part of the light because the light is spreading as it goes through the experiment. So as I've attempted to explain, when the light goes into the gradient, when it reflects, it doesn't get what you could call what's the word I'm looking for? It doesn't diverge. But when it goes through the grating, when it goes through the holes in the silver mirror, okay, so here the light's being shot through, it goes through the holes, this light starts to diverge here, and as it reflects back, it's diverging even more. So I don't even know how to draw it, but it's spreading even more when it hits this mirror. And likewise on this, the path where it reflects, it doesn't diverge until the very last leg of the experiment. So the two have very different divergent patterns. One diverges a lot more, one path, than the other path. So I've made this argument, again, ignored argument, no explanation for how this isn't the truth. So one of these circle patterns is much larger than the other. And those two are being superimposed on each other, and the only part of that that's being viewed, it's being selectively viewed, is this. So they can display the whole thing, or they can display a portion of it. And especially when they use lenses, they're only displaying a portion. So they're imposing this on top of this, and you can see that that's going to create some differences in pattern than what you would expect. Now, the explanation for exactly why there are these subtle differences can go a step further in terms of complexity, in the sense that you have other photons hitting the mirror and creating energy in the mirror by reflecting, and at the same time other photons are going through refracting, and those refracted photons can quite sensibly be being affected by the ones reflecting off the other surface. So I suppose to demonstrate some of that, the two glass pieces I showed in the other video is quite relevant in the sense that you can see that any pressure you place on these two pieces of glass, so there's two pieces of glass and there's dust between the two pieces of glass, and you end up with a pattern on the surface of the glass that has every appearance of a diffraction pattern or an interference pattern. But it's not. It's just being created by the light refracting between the layers of the glass, and more specifically the layer where there is no glass between those two surfaces. And so that's the real mechanism. This isn't an interference pattern, it's a refraction pattern. And what's causing differences is, as you could see, you can just push on these mirrors. I mean, on these, I keep calling them mirrors, they're just plain glass, and you can push on it and you will see a change in the pattern. I mean, it's probably especially works well if you put oil in between two layers of glass, because that complexifies the reflective index, and even with white light, and then you can get the many different colors of this same product. So anyway, back to the crappy video. I think this is the right one. Well, I could show you the other thing first. Well, I'll show that later. Just an example of refraction.
That it works both ways, so to speak. Now, what in Mendel, whether we call it interference or not, to safeguard his sensibilities?
And it's not safeguarding my sensibilities. It's really important to understand. You keep throwing these words around. You keep saying with some authority that you know how they're defined and what the difference is between them. You're so, you're so anal about making sure somebody doesn't confuse velocity and acceleration and all this other stuff. Well, this is really important. You have refraction, you have diffraction, and then you have what's called interference. And they're different functional things, and you're grouping them, you're moving these things into those categories without any evidence that you've properly labeled what's creating the phenomenon. So again, it's kind of important whether this pattern is being created by refraction in the beam splitter or whether it's being created by some kind of real interference between photons.
This arrangement makes we can set it up and get ourselves a nice bright dot.
Alright,
Okay.
so when he says we get ourselves a nice bright dot with both legs open, that's not true. You get this, or you get this. You do not get all on or all off. You get a mixture of on and off. So there is no you get a bright dot and that's all you get, or you get no light and that's all you get. You get this, one of these two patterns is what you're going to get.
And now there's streams. So we're not thinking photons yet or anything. We're trying to explain it, but what we know is that there's either streams of bazillion photons or.
So again, from the two-slit experiment, that whole idea that this is about many photons or photons interacting with other photons, it's already been clearly evidentially proven that this is not a phenomenon created by photons interacting with photons. That's not quantum mechanics.
A stream of continuous waves, some might like to think about, but it's streaming.
So a completely a complete misrepresentation of the science. This has nothing to do with the amount of photons. There's no principle of interference in photons that has anything to do with a collection of photons. That's again turning it back into water waves or something. Yes, water waves, you can't send a single photon of water wave. So you can't do the two-slit water wave experiment with a single atom of water. Because yes, they're not even comparable experiments. And yet you keep trying to do this. You keep trying to turn light into water or some other medium that you can manipulate the same way you can manipulate light, and you can't. So you don't understand any of the underlying theory to interference in electromagnetic waves at all.
So an image here, scenario 1. But in scenario 2, when we move the reflector, you get darkness. Now then.
So again, completely wrong. You get the reverse. You move the mirror, you reverse the patterns. These lines move to new locations as you move the mirror. You do not get darkness or light. The center can go dark or light. Dark or light. But just it's not the whole, all the light going in one of those legs does not go all the light or none of the light. That never happens. It's never all on or all off. That isn't the experiment.
I say, no particle model can explain that darkness in the face.
So again, he's made 2 videos making this assertion, being so belligerent, and again, there's absolutely no obligation for a particle model to fit the non-factual, made-up, fake results that you're describing. Your inaccurate description of the phenomenon, it makes this just an incredible straw man argument.
In the face of the idea of the movement of one of the paths. How could it possibly be that the movement in one of the paths, and remember, each one of these prior images is half coming from this reflected ray and half from the other reflected ray. We've only changed one of the legs. How has changing one of the legs made both half returning lights, so to speak?
Because it's changed how the refraction takes place inside the beam splitter, and it's the refraction of the light that creates the pattern, as I have demonstrated with a clear, obvious experiment. It's just two pieces of clear lens glass, no bends in the glass at all, just flat pieces of optical glass placed on top of each other, and this is the pattern it creates on the surface of the glass. There's no denying this connection between this pattern and this pattern and this pattern.
Turn into darkness, complete darkness.
All right.
What's
so
more,
again, he says again. Just to reemphasize, it never happens that way. There's never complete darkness ever here, ever. Complete darkness unless you block both legs. There's never complete darkness there.
Situation, if we place a card in the beam, we get the re-establishment of streams of particles, making it, again, to this screen.
Right, so half the light goes to one location, half the light goes to the other location with just one arm open. Yes, so you get half a brightness, but it does have pattern in it. It's just the pattern isn't as revealed as it is when you have both of them combined. Now, the explanation for why that happens isn't going to be because the light in this leg, this last leg, somehow the light interferes with the other, the photons are interfering with a copy of themselves. There's no quantum mechanical element here. There's no way for you to even contrive it. There's no Heisenberg or Huygens events in here. There's nothing to create or collapse your wave functions. It doesn't happen in this stream. It happens right here inside the beam splitter that is misidentified as some sort of perfect mechanism that creates two perfectly equal beams of light, when, as I've demonstrated, they're not equal. One has diverged a lot more than the other one as a fact, and we also don't know what the consequences is of these photons interacting with each other, in the sense that they're both hitting the matter at the same time. They're both interacting with the same beam splitter at the same moment.
Mention in one of the legs. How is the returning light in a particle model these streaming particles meeting a solid?
Right. So he asked this question. So here's a third gripe against this garbage argument, is that somehow he thinks, okay, that you block one of the paths and you have no light here, and you have all the light goes here. That doesn't happen. So it's 50-50. There's still a particle explanation for it. So he's still well, it's because he has this presupposition that this was all the way on and all the way off, and so he's thinking that, well, as I pointed out, it's never all on or all off.
However it works, whatever. Beam splitter, yeah, solid particles meeting it, suddenly losing the stream of particles or whatever's been doing on this side by the intervention. These particles and this structure is somehow saying, oh, hang on, he's put a piece of card in. Let's all go back to the source.
So again, he says that happens. So that's not even accurate. So when you put a card in here, it all doesn't there is no dark on one side and light on the other side. They're both 50-50 lights. So they're both half yellows or whatever you want to call it. So again, this is just a false premise, and I would like him to explain whatever he thinks the problem is here with a particle model explaining it. How does he explain it with a wave model? How does the wave model explain what he's saying that doesn't happen? But let's say what he says does happen. You put a card in here and all the photons go in one leg. How would he explain that? How does the wave model explain why no photons go this way? There's no wave explanation for that. So, this is bogus on so many levels. The challenge that a particle model must explain something his wave model doesn't even explain. Another dodge, another tactic used by these people, just like when they claim I have to explain, the imposition of two of the what they call the diffraction envelope that the double slit experiment pattern falls into. So it falls into the single slit diffraction envelope. Well, they don't have any explanation for why that happens, any mechanical explanation, and yet they'll challenge me to explain it. And again, and when I do, they ignore it. These people are just so duplicitous.
Yeah. You just can't do it. You can't do it. I mean,
you can't do it either. And it doesn't happen, so fortunately neither one of us has to explain it, because what you're saying happens doesn't happen.
If you can do it, why didn't DraftScience do it and explain it? No, he had to talk about something different, about the splicing of two glass surfaces with fine layers of dust particles.
Right. So I talked about the actual mechanism because I pointed out how this pattern doesn't meet the obligations of an interference pattern. It is not. The thicknesses of these bands is not consistent with an interference pattern. They go from thick to thinner and thinner and thinner. It's different than an interference pattern. Interference patterns don't make the outside gets dimmer, it doesn't get smaller. So if this pattern got dimmer, but it was all consistent thicknesses, then you could argue this might be an interference pattern. But it doesn't match. And all these subtleties are so important. And so you're the people who are just not, you're not paying any attention to detail. You're not looking for the correct answer. You're just arrogantly, obnoxiously preaching your dogma. You keep forcing your God theory of the truth and telling me I must believe God created the Grand Canyon and God did this and God did this. And you have these preposterous justifications and explanations for how your God does it with your Huygenses and your Heisenbergs.
And talking about the many probabilities which would go on there, and each probability and each path being in regard of one particular photon. It doesn't. This scenario and discussion doesn't entertain the paradox of the changing circumstance.
Well, it doesn't entertain a paradox that doesn't exist. Again, it doesn't happen as you're describing, so I don't have to explain it. When I block one of the paths, 50% of the light goes here and 50% of the light goes here. Oh, sorry. I'm playing the video. Yeah, sorry. So you lost whatever pointing I was doing before. So let me... I don't think I drew anything. Is there something I did say, though? Well, anyway, I'll go back to it later if I have to. Sorry, I forget the drawing's not on the screen at the same time.
Of scenario 3. And what must be necessary hypothesize in order, incredible, unpalatable, unbelievable hypothesize that somehow these photons, because
I mean, all these hyperbole, all this excessive rhetoric, all this arrogance in the face of a completely stupid misunderstanding of the fundamental mechanisms of the experiment. The fundamental truth of the experiment is ignored just to be a pontificating, arrogant dogmatist.
Blockage here somehow don't, or when there's not a blockage there even, should I say?
I didn't touch anything.
Should I say, why they aren't making it to the screen. It's fantastic. It's phantasmagorical.
So again, all this excessive rhetoric for a circumstance where he's completely inaccurate, he doesn't understand the experiment, and yet he's talking with such arrogance.
The notions that need to be entertained to account for this anomaly of the introduction of a beam splitter wherein half goes back to the source and half goes to a final screen. Yeah?
Right, so he understands that's how it works. When you block one of the paths, half goes one way, half goes the other way. So again, what's the problem? So he doesn't even, he can't even be consistent in how he's describing his dilemma or problem.
And the establishment of an image, the getting rid of an image, and the semi-returning of an image by virtue of the introduction of a blockage in one of the paths, and that adjustment of distance in one of the paths causes darkness.
So again, he doesn't understand. It doesn't cause darkness. It just reverses which path pattern arrives at which location. That's all it does. The photons that were going here stop going here, aren't taking this path, and they're taking the other path and showing up at the other location. Reverse that, but you get it. I mean, the way I drew it, the darks and the lights are, confused.
The physical hypothesis is therefore streams of photons. See, you can talk about, probabilistically.
Yeah, so again, the fundamental misunderstanding whatever he forgot, that a fundamental premise of quantum mechanics is that this is a phenomenon that each photon expresses its wave function, and that different photons cannot combine their wave functions.
Joe here might go back home, but you can't say in a 50-50 beam splitter that Joe, Ernie, Tom, Peter, Sam, and Gary all forever, and all their buddies decide to go back home to the source because of an introduced, because of a change in the distance. Yeah?
Yeah, but what you can say is the change in the distance changes how these two patterns interact with the beam splitter and end up overlapping on each other. And I'm pointing at it again. Yeah, I gotta find a rule that prevents me from making that error. So what you have to account for is the fact that the two beams are not the same. They're first different sizes because of the divergence. The fact that one path diverges a lot longer than the other path diverges. And secondly, they're interacting with this material at the same moment. These photons are interacting with each other as a stream of photons. And so now photon can interact with photon in this experiment, but not in an interference way, but in a refraction index way. They change the refractive index of the medium by disturbing it. These photons are hitting it, they're creating vibrations in the mirror that are changing the refractive index, how the light will exactly be refracted, which changes the patterns, that shifts things, places where photons did refract to, now they go through the medium instead of reflecting off of it. It changes how many reflections you get in these in the material. So to emphasize that point, I did notice, I'm just playing around with a magnifying glass, that you have these reflections off the glass, and so you get. So there's a chandelier over my head, and so this is just looking down at a convex, regular magnifying glass. And so there's two reflections of the 5 bulbs of the chandelier. and the one reflection is small, which means it's probably coming off the bottom surface that's, you know, concaved, or however you want to describe it. That's going to create a focal point, and it's obviously more in focus. So the small pattern is in focus, and it's also aligned correctly in terms of orientation. So you can sort of see there's two, and then there's just one at one end. You know, the hexagon, the flat side of the hexagon and the pointy side. And the other image is exactly reversed. So the pointy end is reversed. So the top image, the bigger image of the 5 bulbs, the less in focus image, which I can't really explain, is one where the beams of light have obviously crossed in space to create the image. So if you move the glass, the top image, the big image, will move more than the small image, which also indicates the small image is coming off the bottom plane of the glass, where this top image is coming off maybe the surface of the glass. But I don't know the details, and I certainly don't fully understand why the reflection on the surface glass is reversed. Because it's the reversed image. I intuitively thought the bottom image should have been the reversed image, and yet it's the top image that's reversed. So I'm just saying the same chandelier is being reflected in just a millimeter of glass. Somehow, not only are the sizes different of the same image, the focus is different, and on top of that, one of the images is reversed. So this isn't so simple. And so for him to sit there and do that little, oh, Minden brought up this stupid refraction stuff like it's, you know, something important, but it has nothing to do with any of this. No, it's the very function of this experiment. This is exactly what the experiment's doing. This is a video, so I'll see if I can play it. It's a weird player. It doesn't have any buttons on it, and all I can do is stop and start it with the space bar, which is quite funny. But you know, it's Linux. I mean, VLC wouldn't play the video because I guess I'm short on resources because I have all this other, all this other software running. So you can see the top image is it appears to be the surface image because that's the one that moves easily. And the bottom image just stays dead solid. Now that might be quite opposite, right? It's really hard to figure out, but I have to say the bottom image has to be, the small image has to be coming from the bottom because that's the concaved surface, that would create a focus. But look at the two images that are reversed. Now there's the fifth light bulb there is cut off because I think that's the camera actually that blocked part of that light. So I think it is. But the fact that the mirror, yeah, it doesn't move at all as I move the glass. So yeah, it's hard to say. So the player just ends and I have to reload the player. It's just it's a weird video player. But anyway, so let's finish up the video, I suppose. Which must be this one, I guess. Bring this back. Oh, that didn't work. Oh yeah, that's the video. It didn't work. It's Daftloaday's ugly glob. His glob.
And if you did say, yes, all the army now are all deciding to go back to the source, yeah, they're all returning home because of this change in distance, yeah, then why, blocking one of the paths, does this half of the army suddenly decide to not go home? Yeah, not go back to the source and give us scenario 3.
So it's just so presumptuous because even if that were true, and it's not, how does his wave experience? How does his wave theory explain why all the photons are switching paths? There's no wave theory for that. The only theory there is I have to switch again. Switch back to the frickin' drawing. Again, we're talking about whether the interference is happening here. This is where classically they would say the photons have now been combined back together, and the two waves are going through this you know, you have the, let's see where, yeah, I can draw over here. So you have your beam splitter, and somehow your two photons are meeting up, you know. Let's see, you know, one will be coming from this way, one will be coming from this way. So one will reflect, one will go through, and so now your photons are meeting up. And the theory is they're creating two waves here that are interfering with each other, and that somehow is creating your difference in the pattern. But how would that theory explain why all the photons went this way, or all the photons went this way? How would this theory of interference explain changes that had to happen before or at the beam splitter? So his own theory doesn't have an explanation for this fake straw man argument that he's making. And yet he claims no particle model can explain it. The truth is no wave model could explain what he's saying is happening that isn't actually happening, so nobody has to explain it. But again, I'm going to argue, how dare he be so fucking wrong? First, to ask why doesn't particle model explain something that his model doesn't explain, and then on top of that, to be just completely fucking wrong about what actually has to be explained. I mean, it's just, you're not only wrong, you're so fucking wrong, to quote petty Weasley's trolls like yourself. So let's play the end.
Is that clear enough for the dummies out there?
So I should just, you know, post that as what? Should I just play that over and over again? I mean, it's just, you're just so obnoxious. This whole conversation, you just keep being this obnoxious, belligerent, inaccurate, exaggerating, you know, you know, you don't have any competence to be a for dummies author, because you clearly haven't thought about it, you haven't watched enough, you haven't seen enough to understand what the actual experiment produces. And this is a common and pervasive problem with arguments with you jackasses. So, fuck you. There's nothing to say. This is just so fucking unacceptable.